So what we're doing today also is we are finishing up the note sheet from so we're going to finish up the note sheet from Friday. I believe we did this multiplication problem already. We already did this one here, yes. So I want to look back at this one since did we do this one? Okay. I didn't know if we did this multiplication or not. Okay. So one thing I want to look at is you don't have to write this down, but if we're dividing, we have not gone over rewriting radicals yet. So f of x over g of x, which in this case would be x squared over the square root of x. Now, you have learned, and we've taught and kind of gone over in Algebra 1, how to simplify or rationalize the denominator. We cannot leave it, and we're not supposed to leave the square root in the bottom of the fraction. And the only reason that I've seen or kind of come across for this is because we don't want to leave an, or in this case, a possibly irrational number in the bottom of the fraction. Because if x is not a perfect square, we have a non-repeating, non-terminating number. In the denominator, we're dividing by it. So that's the only reason that we wouldn't put it there, or leave it here. So for this assignment, and for this one here, this is the final answer. We can leave it as this here. Because normally we would have to multiply by the square root of x to rationalize it, telling us that we have x squared times the square root of x over x, which would just be x square roots of x, because it would simplify down. But for this here, in the homework, we can leave it as this here. We can then find f divided by g of 9, which would be 9 squared over the square root of 9. 81 divided by 3, which would be 27. And we also haven't gone over how to rewrite radicals as fractional exponents or as an exponential form. That is a part of chapter 5. It's just earlier on in the chapter. So not going to cover either one of those there. Yes. I think you're saying we did this one already. Because this is where we got to. F divided by g of x. Well, f divided by g of x is just saying that we're taking f of x and dividing it by g of x. And f of x for us is 6x. And g of x is x to the 3/4. So this here is actually a radical. Part of it is. Because when we have these fractional exponents, we're saying how many times we need to multiply to get it to be 1, but that's fine. So what we're saying here is that we actually have 6x over x to the 3/4. And even though it's not written, the exponent on top is. Questions on this so far? Now this here is going to be kind of nice to simplify. Whenever we divide like bases, we subtract the exponents. Even though one of them's fractional, we still subtract the exponents. So really what we have is x to the 1 minus 3/4, and 1 minus 3/4 is 1/4. And we'll simplify to this here. Now, main reason we're simplifying this, unlike the others, is this is actually not a bad simplifying process, because we're just subtracting the exponents, getting 1/4. So f divided by g of x is 6 to the 1/4. 6 times x to the 1/4. And then they wanted us to evaluate this when x is 16. So really what we're saying is we want to figure out what 6 times 16 to the 1/4 power is. And 1/4 powers are really saying what times itself 4 times is 16. So it's really 6 times 2, which is 12. Or we can grab the graph or a calculator and say 6 times 16 to the 1/4, which also tells us that it is 12. Questions on this here? Because even if we left it as 6 over x to the 3/4, 6 times 16 over 16 to the 3/4 still gives us 12. It is the same value. Questions on these here? F divided by g of x. So f of x over g of x. In this case, f of x is 4x. G of x is x to the 2/3. Now, since they're already written in exponential form, we're going to go on and simplify it down from here. If it had been written in radical form, for this time only, we'd leave it. We just keep it there. But since they did give it to us in this form here, we're dividing like bases so we can subtract the exponents. So we'd have x to the 1 minus 2/3. 1 minus 2/3 is 1/3, so 4x to the 1/3. Now, we can only do this with exponents. Radicals, it does not do it this way. We cannot divide two radicals by subtracting the exponents. We can, but we'd have to change it from radical form to radical form to, I'll just call it a and a, to a rational exponent, fractional exponent over fractional exponent, then subtract the exponents. We have to get it into exponential form before we can do that. We can't just do that with radicals. F divided by g of 27 is 4 times 27 to the 1/3, which, funny enough, is 12. Because 27 to the 1/3 is what times itself? 3 times is 27, which is 3. 4 times 3 is 4. Questions on this here? Are you ready for the next one? Okay. F plus g of x and f minus g of x. We want to find what they are. We're not worried about the domain because it's really the domain for any of these sum, difference, product, and quotient is we look at the domain of both and combine them and what's included in both. They're both to the 2/3 or 1/3 power, so they're cubed roots is what they would be if, and again, we'll talk more about it after spring break. We'd be able to see and identify it. Cubed roots are all real numbers. Both of them are all real numbers, so everything's included in both. Domain's all real numbers. Now, f of x for us is negative 2x to the 2/3. And we're going to add to it g of x, which is 7x to the 2/3. Now we don't need the parentheses, it just stays the same, negative 2x to the 2/3 plus 7x to the 2/3. Since both x's are to the same exponent, that means they are the same. So we can combine or add the coefficients, telling us that f plus g of x is 5x to the 2/3. Now before we evaluate when x is 8, might as well find the difference. F of x minus g of x. Well, f of x is 2x to the 2/3 minus g of x, which is 7x to the 2/3. Now it's a little bit different this time because when we subtract, we're now doing negative 2x to the 2/3 minus 7x to the 2/3. Negative 2 minus 7 is going to be negative 9. Telling us that our difference is negative 9x to the 2/3 power. Questions on this here? Now for this problem, it wanted us to evaluate each of these when x is 8. Five times 8 to the 2/3 power. Now we do have to be careful when applying exponentials with fractional exponents, depending on if the number is positive or negative. Because if it's negative, for the most part, it doesn't make a big difference unless we're talking about even roots. Because if we have a positive number or a negative number in an even power, it doesn't work well. So we have to be careful on how we apply negatives and even roots to it. But for the most part, we type it in exactly like we have it, and the calculator will tell us exactly that this is 20. We're going to do the exact same thing for our negative 9, parentheses 8 to the 2/3 is negative 36. And that's it. Questions on this so far? So for this one here, we want to find f times g of x. And f divided by g of x. So here we'd have 3x times x to the 1/5. Now we'd multiply the coefficients of numbers first. Well, that's 3 times 1, which is just 3. Now our x to the first times x to the 1/5. Now we haven't been writing it out for the most part, but we would add those exponents. 1 plus 1/5, telling us that it's x to the 6/5. And that's simplified form. Now it's mainly because we're multiplying like bases, we add those exponents. Now our f divided by g of x would be f of x over g of x. F of x is 3x. G of x is x to the 1/5. Since we're dividing like bases, we subtract the exponents. Now luckily for us, And this here, the exponent on top, the variable exponent on top has been bigger than the denominator, so it's just going to stay on top. Because if the exponent had been bigger on bottom, we would have done 1 minus, say, 6/5, would have given us a negative exponent, which would mean we'd have to put it back on bottom. Right here, it worked out that both of them were bigger on top, so they're going to stay on top. Now this one, they wanted us to evaluate it when x is 32. So we have 3 times 32 to the 6/5, which is going to be not a big number, but it will be decent. Make sure I got the right number. 32. That makes more sense. Because 32, unlike 64, actually has a 5th root. I did that I plugged the wrong number, because 32 to the 6/5 would be 64. Because the 5th root of 32 times itself 5 times, what times itself 5 times is 32 is 2. 2 times itself 2 to the 5th is 32. So really what we're saying is that the 5th root of 32 is 2. Then we put 2 to the 6th. 64 times 3 is 192, which is our answer. 3 times 32 to the 4/5. 3 parentheses 32 to the 4/5 is 48. And 32 to the 4/5 is actually 16. Questions on this here? And the domain for the product is going to be all real numbers, because x to the 1/5 is a 5th root, an odd root, so it's all real numbers. 3x is also all real numbers, so it's all real numbers. However, the division, g of x cannot be 0, and the only value of x that would make it be 0 is 0, so it'd be all real numbers except 0. We have to exclude it from the domain. But last thing we're going to do is going to require graphing calculators. Welcome. Welcome. We've already gone over this, what we're about to do. So this here, let f of x be the square root of x, and let g of x be the square root of 9 minus x squared. We want to find the sum, difference, and quotient, and product when x is 2. So what we're going to do is you're going to get the graphing calculator, and we're going to hit y equals first. So hit y equals, and in y1, we want to plug in f of x, so the square root of x. Because if there's anything in there written, we'll clear it out. So we'll say second square root x, second square root 9 minus x squared. Are we able to get those two equations typed in? Once you get them typed in, second quit. Because what they want us to do is to find f plus g of 2, or f of 2 plus g of 2. We want to add these two values together. Now we could go about trying to find out what the square root of x plus the square root of 9 minus x squared is, Well, square root of 2 we know for certain is not a nice number. And most likely 9 minus 2 squared is not going to be a nice number either. I wouldn't type this in yet because the one way we can do is I can go second graph and see that the x, or for f of x, when x is 2, the y value is 1.4142, so on and so forth. G of x is going to be 2.2361. We can add those together and get 3.6465 because it is going to round. That next number is going to give us a 0. We can do that there. Or alpha trace, alpha F4. So hit the green button, F4. And you should get this here. Now we put f of x equation in y1. So I'm going to hit enter to get y1. Parentheses to close parentheses. So what we're telling it here is that we want it to take that function and plug 2 into f of x. 2 into that equation for f of x. And that's fine, but we want to add to it what? Alpha trace y2, and we want its value to also be 2. Did we get this typed in? Hit enter. .65. Rounded to 2 places, that's our answer. Questions on this here? And yes, especially on the ACT, they give us an equation which of the following values is the solution. We could plug that equation into y1 and go alpha trace y1, answer choice A, and plug those in and see which ones give us the correct value. Now, we also want to find subtraction. Almost. There we go. So 3.65. So we do alpha trace y1, parentheses 2, close parentheses, minus alpha trace y2, parentheses 2, close parentheses. And it tells us it's negative 0.82. 'Now, yes, typing alpha trace, doing that time and time again can get a little tedious, yes? Hit the up arrow twice and have it select that previous one and hit enter. Because if I do that, I just got a cursor over and replace the minus with times. And it tells me that y1, when I do it with multiplication, we get 3.16. 0.63. Questions on this here? Now, really, if they gave you, especially thinking of this in terms of solving, I would use get it equal to 0 or set both of the two sides. One of them is y1, the other is y2, and subtract them from each other. because if I subtract the two sides from each other, it should be 0. If it gives me 0, that means they are equal to each other. Does that make sense? Yeah. Well, that's it.